Hello everyone, welcome to the Analytic Moment. I'm Quentin Fisher, CEO of Healthcare Analytics, and this is a series on artificial intelligence for healthcare service providers. Last session we talked about how to move from historical reporting to prescriptive and embedded AI solutions. Today's session we'll talk about some principles and a high-level overview of big data. Now the key thing that a big data architecture allows in my mind is agility. Even if you don't have a very large or huge amount of data, a big data architecture can provide you with a lot of flexibility. Well, how is this? Well, with traditional database structures, you actually need to structure 100% of the data when you write it to the database. They call this structure on write. The problem is that you may not know how you want to structure all the data, how you want to slice and dice the data, and as a result, a lot of work has to be done to provide this structure for 100% of the data before you write it to the database. And then unavoidable changes will happen to the structure as you learn more. Now, with a big data infrastructure, the databases are typically based on these databases called NoSQL or Not Only SQL. These don't require the rigid structures to store the data, and they actually store a lot of unstructured data, which as a side note is really 80% of the data out there is either unstructured or semi-structured. But in order to use this data, you still need to structure the data, right? In this case, you structure the data when you read it from the NoSQL database, and they call this structure on read. And now this has many benefits, being that you don't need to structure all the data before you store it on the database, right? You can load all the data into this big data environment. A lot of people would call this a data lake. And then you determine what exactly you want to structure, right? The benefit being that the amount of time spent on structuring the data, you only do that on the data that you need. And this could be 20, 30% of the data versus everything, right? And if you need to change the structure, it's a less intrusive effort, okay? Now, traditional databases, for the most case, are scaled vertically. Basically, that means they put bigger machines in place, right? However, big data architectures scale horizontally. This means that machines run in parallel, and they allow a much bigger data set to be worked. And for our purposes, there really places no limit on the amount of data that we can process. So now that you have this very large, flexible infrastructure with big data, you can now mash up both structured and unstructured data. The NoSQL database allows both of these data types to be integrated. Now, with this in place, you can mash up data from different sources. You can combine various sources of data from private data that you have within your financial, human resources, your electronic health record, or pharmacy, or lab systems, right? You can also pull data from shared sources. Maybe there's standards, ICD codes, clinical trial data, quality reports, all this that many organizations have access to. And there's also public sources of data as well, like demographic data, weather, socioeconomic, location data. There's a lot of sources. So now that you have access to all these data sets and they're from various sources, when building AI, we all know it's about the data. Now, there was as a proof point, there's a great competition by Netflix where top-notch algorithms competed against more basic algorithms with a broader data set. In this instance, they combined the Netflix data set with the IMDb data set, that's for the International Movie Database. And guess which algorithm or which solution won out? It was the more basic algorithm with the broader, more robust data set, okay? So when we build our algorithms, we're going to use a mashup of data so that we can get a well-rounded perspective on the problem. And then we allow the machine learning to build these relationships. Without the data in place, there's really nothing to feed the beast or this machine, right? And to produce these predictive results. So you really need the data to drive the solution. So in summary, we talked about some of the basics of the big data architecture, the structure on read versus structure on write, scaling vertically and horizontally. Next week, we want to talk about AI and machine learning and what to do with all this data that we now have. Thanks for listening. Please subscribe to the channel. Let us know your point of view, any questions you have in the comment section below. Also, get on our mailing list at hcanalytics.net. Take care. Bye.